Hello everybody, this is David with another Verilog and FPGA video. Keeping on with the PicoBlaze. Last video I did the intro. Here I got another program to try, and I'm going to do it on the Nexys A7. So here's the block diagram, essentially what's going on. I'm using the Nexys A7, using 8 switches and 8 of the LEDs. So 4 of the switches will be used as operand A, and the other 4 will be used as operand B. And the program that is written in assembly is calculating the result of A squared plus B squared. So it's a sum of squares, and we're using the 100 megahertz for some logic in here, and we're going to use a right strobe signal that comes out of the PicoBlaze microcontroller for logic in the top. If you didn't watch the first video, my intro, this is essentially the Verilog file that comes from using the assembler program. So if you don't know how to use the assembler program, go back where I explain how to do all that. And it's just driving the result of A squared plus B squared on 8 LEDs. So this is essentially the flow of the program. First thing we're going to do though is clear memory, and then we'll just loop through, read the switches at the input port. We'll strip off A and strip off B and some other part of programming, but essentially we're calculating A squared plus B squared, and then we're going to send that result to the LEDs through the output port. Let me take you over to the assembly program. Okay, here's the assembly program for this project. I am using this from a reference book. It's an older book from 2008, and they use KCPSM, which is PicoBlaze version 3, and so I kind of updated a little bit. I'm using KCPSM version 6. That's the current version they have out now. The program is pretty much the same. I just included a whole lot of notes to clarify a whole lot of things. So just to go through the program here, like I said, it just reads 8 switches, calculates A squared plus B squared, display the result on 8 LEDs. So coming down here, remember in assembly programming, the semicolon represents a commented line. So, and then where there's no semicolon is code. So we have the constant here, just setting up a nibble, 0F, here it is right here. So we're going to mask the switches to obtain the lower nibble, which is A. Here's setting up a bunch of symbolic memory addresses by address. So we're going to have, you know, the least significant of A bit of nibble or whatever of A nibble, yeah. And then double A, you know, multiplying them or squaring them. Same thing with B, and then A and B. Right, so just symbolic locations for memory. And then here's register aliases, so using the name reg instruction for the PicoBlaze, creating symbolic names for some registers. So I'm using register 0 called data, register 1 is address, register 2 is I, used for a loop index. And then there's one global variable, same format, but so I'm using register F for the switch-in values. And then here's the port addresses for the input port. Is called switch port. I'm using port 1. The LED port is port 5. These are all hex values, by the way. PicoBlaze uses hex values numbering system. So this is the main program right here, and this is the calling hierarchy. So the first thing we're going to do is clear data memory, and each of these ones with the line here is a subroutine, and I'll go through the subroutines here in a minute, really quickly. But clear memory, then we're going to loop through, read the switch. We're going to get A, we're going to get B, or actually this is A or B then A, but it's getting A and B, and then we're going to square them, and then inside of the square we're going to call another routine that's going to multiply A together, multiply B together, and then in some more code we'll add them, and then write the LEDs. And then this is the actual program for the main memory right here. These are the instructions. We're going to call this routine to clear the memory, and then forever is a loop. So we're going to call read switch, we're going to call square, call write LED, and then head back up to the top and just keep doing it over and over. So then now all you got to do is define all your subroutines. So right here, this is to clear data memory. So we're going to load I with a value of 40, which is hex, but it's 64 in base 10. And then we're going to load data with 0, and then we're going to go through each memory address. This is how you loop through decrementing I, and until we get to 0, we're going to keep going. And then every value of I, which is the memory address, we're going to store data in it, which is 0. So we're going to clear the memory. And right here, we're going to read all this. We're going to read the switches. So we're going to put it into our symbolic switch-in register from our symbolic switch-in port. We're going to load that value into data, which is a temporary register. And then we're going to call the subroutine get lower nibble. So that's how we abstract A from the switches. And right down here, it's get lower nibble. So it's anding that mask up there with the data. So we'll just abstract A. And then coming back up here after we have called that subroutine, then we're going to store in the memory location the value that gets stored in data when we call this routine, and store that into the memory location. We're going to do the same thing for B. We're going to get the switch-in value for B, put it into data, or the switch-in value, put it into data. We're going to call get upper nibble, which is right here. Just right shift 4 times, and you put the upper nibble into the lower nibble, and we can come back here, and we essentially got B now. So we're going to store that into what's in that data into the memory address for B. And so the next part of the program is squaring. So we're going to calculate A squared, B squared. So these two right here are pretty much the same for A and B, and then this calculates A squared and B squared. So we're just going to fetch from memory and put it into a location A twice in 2 different registers. Then we're going to call the mult-soft program or routine. So if you come down here, this is the routine. It uses a shift and add algorithm to obtain the value of A times A and B times B. And that's what happens here. We're fetching, and then we're putting AA in the LSB and storing the MSB, because when you multiply 2 4-bit values, you're going to get an 8-bit value. So we're going to have our lower nibble and our upper nibble. It says byte, but it's nibble. And let's see, same thing for B here. And then we're going to grab A squared, and we're going to add it to B squared and put it in data, which is essentially register S6 still has that value that we stored in memory for B squared. Then we're going to store that into AABB, which is it's the lower nibble of the addition. And then we're going to do the same thing and grab the upper nibble of addition. And then for the carry, because if you can have a carry out, we're going to store that as well. It's not going to read out on the LEDs, but it's still going to get stored in memory. And then the last part, once we have all that, we just write to the LEDs. Here's our write to LED routine here. We're just going to fetch that data that is A squared plus B squared from memory. And then we're going to send that data to our output port, which is our LED port. And that's the whole memory. So let me take you to Vivado. Okay, so once I was done with that program, I saved it as square.psm, and then I opened up the assembler program that came with PicoBlaze. When you unzip the folder, the .exe file, making sure to have that ROM form.v file in there. And then I got my program ROM, my instruction memory right here, and then I just instantiated just like in the intro. It's the same instantiation. Here's the top module here, just grabbing all of those signals and the processor and the memory itself and copying it in here. Change the name of the memory to square, because it's now square.v, which was based off of my PSM file, which was called square.psm. I am going to leave this disconnected, this RDL, like I did before. And then there's a little bit of logic I added in here. So, well, of course, from the top I have the 100 megahertz coming in, 8 switches and 8 LEDs defined right here for the top. Now I'm defining an LED reg for the right strobe, because you have to qualify according to the manual. If if you get into that manual, you have to qualify your outputs using the right strobe. So that's where I'm using the right strobe in my logic down here. So always at the positive edge clock, I want to set the register of the import equal to the value of the switches going into the microcontroller. And then coming out of the microcontroller, I want to use that right strobe signal to qualify the output and store that which is coming out of the output port into my LED reg. And then I'm assigning the wires that is the LED that's coming out of the top equal to the value of the LED reg, which is the output port. But I'm qualifying that using the right strobe. Before I haven't had that, but I'm adding this in now after reading the manual some more. And that's pretty much it. Here's the constraints file. I just have the clock, 8 switches, 8 LEDs on the Nexys A7. And now let me show you it working on the screen, or on the board. Okay, here's the Nexys A7 sitting right here. I got it all programmed up. And these 4 switches down here are A, these 4 switches are B. And the results on these 8 LEDs here. So that's 1 and 0. So I can do 2 squared. Let's see, this is 2. That's 2. So 2 squared plus 2 squared is 4 plus 4 is 8. It's correct. I mean, this thing works. I went through and checked all the values and stuff. But so 10 times 10, or is that right? So I got 10 there and 10 there, yeah. But that's 200. So that's 128, 64, and 8 gives you 200 there. So it's working. Now you might ask, like, why would you want to go through all that assembly programming when you can instantiate something like this in hardware much easier? And it's just an example in using the PicoBlaze. I'm sure somebody will figure out a very cool thing to do with the PicoBlaze. This is something real simple, but it's a little bit more involved than the previous one. So hope you enjoyed the video and learned something like I did. Thanks for watching.